Okay, let's get started. Welcome everybody. Thank you for joining the webinar covering what's new in Femap version 2019.1. We are Structures.Aero, and I'm David Cross, an aerospace engineer at SDA or Structures.Aero. Today I'm going to give you a little bit of background on our company and who we are and what we do, and then I'm going to do a live demonstration to show you some of the cool new functionality and updates within this latest release of Femap. And then after the live demo, I'll go through some slides and point out some other new functionality and updates that are in this latest release. And we'll have a discussion, and I can answer any questions that you may have at the end when we wrap up. So who is Structural Design and Analysis, or Structures.Aero? We're a group of about 14 engineers, and we help our clients in the aerospace industry and some clients in other industries as well design lightweight and load efficient structures, right? And we specialize in composites, and we use a variety of tools to provide these services, everything from hand analysis, obviously Femap and NASTRAN, Hypersizer for some of the more detailed composites analysis and design, FiberSim, NXCAD, Solid Edge, Simcenter, Dyna, and LMS. In addition to providing structural analysis services, we are also a value-added software reseller, partnering with Siemens and Hypersizer. As I said, we're comprised of about 14 engineers. We have a mix of degrees in aerospace and mechanical and engineering science and mechanics. Many of us graduated from Virginia Tech, but we all are experts at Femap and NASTRAN and use it every single day. Here's just a quick sample of some of the projects we've worked on over the last several years as a company. You can see we've worked on space structures, aircraft, both some commercial and general aviation, UAVs, and then even other kind of out there projects like Hagler dredges, something that's non-aircraft and non-spacecraft. Everything from private aerospace, commercial, and even some government work with NASA on the WFIRST telescope. So a good mix of projects, which really gives us a good background in using Femap for lots of different applications and lots of different types of structures. And a little more detail on our role as a value-added reseller. Right, we provide training and support for these software packages. We try and do these webinars on a monthly basis, and we post them to our YouTube channel. You can just search Structures.Aero and find most of them there. And then also one of our engineers who used to be with the company, while he was at the company, realized there's not a good beginner's guide out there to learning Femap. And so he wrote and published a book that's by Eric Gustafson called Learning Femap. Okay, so what I'm going to do first is jump right into our live demo. And one of the new features in the latest release is that in the Windows File Explorer, when you're browsing, if you have the preview pane on or icons, you can see an image of the save state for that model, which just makes it a little easier to recognize. And if you hover over it, it gives some data there on the version. You can see version 2019.1, the size, the save date, and then this is a pretty simple model right now. It just has one solid entity in it, but it lists all the entities that are in that model. So you have nodes, elements, things of that nature. That information is right there before you even open the model. So what we're going to do today is I'm going to slice the solid, and then we're going to mesh the bottom plate with hex elements and show you some new functionality there. And then the cylindrical body we're going to mesh with tetrahedral elements. And I'm going to show you how to transition. This is a new functionality in the latest release, transition from linear hex elements to parabolic tet elements, right? And why would we do that? If we wanted to capture the curvature in this fillet, because it was a critical stress area sometimes, but it's nice to have nice hex mesh on a nice uniform plate like this. So as we go through, I'll point out other new functionality in user interface features and things of that nature as we go throughout this demo. And then at the end, I'm going to show you something pretty important about buckling analysis and how you set up subcases for buckling that's changed in version 2019 compared to the previous versions. So make sure you stick around to see that. Okay, so the first step, we can see in our model, we just have one solid in our model. So the first thing we're going to do is we're going to go to Geometry, Solid, Slice, and we're going to slice along the face. And if I move quickly throughout this webinar, just know that I'm doing so to kind of keep the pace going, and then I'll pause when we are looking at new functionality of the software. And we post these recordings, so you can always go back and pause if you want to see some of the commands we're executing in more detail. So a long face, and then I'm just going to pick this top face. So now we've sliced it into two bodies. And the next step is we're going to mid-surface this bottom plate. So I'll say Geometry, Mid-surface, Single and Solid. I'll grab the bottom surface, okay, and then the top surface, okay. And now we're mid-surfaced, and I'm just going to hide that bottom plate. And now what we want to do before we hex mesh so that we can transition from the hex to the tets is make sure we get the boundary curves of the cylinder, of the fillet and the inner radius projected onto the base plate. So to do that, we'll go to Geometry, Curve from Surface. You can either do, in this case, we can do Project or Project Along Vector. So I'll pause here and point out something that on the dialog, the Entity Selection dialog menu, they've changed some buttons. First thing you'll notice is the Select All button now has the icon, and it's sort of like a globe, right, indicating that when you press Select All, it's going to grab everything in the model, not just what's visible. But now they've added this quick Select Visible button, the magnifying glass with the eye, and that will only pick entities, add entities to the selection that are visible in the graphics window. So if you have things hidden, like the view deselected in your model info tree, or you're only showing certain layers or groups and things are hidden, then those entities won't be selected. Likewise, if you have entities hidden with the Draw Erase toolbar, those entities will not be hidden. If you're zoomed or panned, zoomed way in or panned way off to the side of your model, it's not just going to grab what's on screen, but what's technically visible in the model. So even if you're zoomed way in, it's still going to grab everything whose visibility is turned on. There's no longer a, well, this is a reset button, this red X, but it used to say reset, and now it's just the red X icon. And then everything else is pretty much the same. They've widened this so that you can see full 8 digits ID in these boxes, which before they were more narrow and you couldn't see that. Okay, so we're going to project onto our base plate surface, and then which curves, I'm going to grab the outer of the fillet and then the inner radius, and I'll just highlight to confirm. I'm going to say okay, and then cancel. So now we're projected onto there, and now the next step is we're going to mesh the base plate surface with plot only elements. So we'll mesh it with plot only elements, and then we'll extrude up and down to fill in the solid with hex elements. And that's one of the new features, is the ability to extrude in both directions. So I'll show you that and how that feature works. So the first thing is we're going to set our mesh sizing. So I'll say mesh control, size on surface, and I'm going to grab all 3 of those surfaces. I'll say okay, and I'm going to set the size to 3. I think this model's in millimeters, so 3 millimeters, and then cancel. And now we can mesh those surfaces, and I'll just select previous and say okay. And then I'm not going to select a property at this stage. We'll just mesh with plot only elements, because we're going to extrude them and then delete them. So now we have our plot only elements, and the next step is to extrude. So if you go to Mesh, Extrude, you now see Curve, which I'll curve element and element face, and there's more extrusion features that I'm going to talk about after the live demo that are new as well. But this is just one of them. So we'll just say Mesh, Extrude Element, and then we can say Select All. Okay, and we will just extrude by vector, but now we can extrude it in both directions, where before it would only extrude in the direction of your vector. So now we can pick a vector going from the mid surface to the top of the base plate, and it'll extrude in both directions. And if we say along length 2, that'll extrude 2 up and 2 down, and then we'll say delete the original element, so we'll delete the plot only elements that we extruded. And now we have to define a property, which we don't have yet in the model. If we drop down model, we don't have any materials or properties. So I'll select the property, and this will be a solid element type, and we need to create a new material. And this is something else I wanted to show you. If we press load to load a material from a library, this dialog menu has changed and been updated and is much better. Gives you a lot more flexibility to manage the libraries. So first you'll notice that we're under Femap standard libraries. And if you drop down the libraries, you can see the 4 material libraries that come with an installation. And then you can see the materials that belong to that library. If you press the information button, you get a nice description of the library. And this is an SI model, so I need to change to a millimeters library, and we can just pick some sort of aluminum. Let's see. We'll just pick 2420 aluminum, and we'll say load. And then we can say, okay. So the one thing I didn't mention is there's also a personal tab. So these are the Femap libraries that come with installation. And then you can also save and manage your own libraries under your own path and see those all here on this menu. Works the same way. And this goes not just for materials, but properties and layups and anything, any other entities for which you can create libraries. So with our material and our property defined, we can now execute our mesh extrusion. And we have to pick a vector. So I'll turn the base solid back on, and I'm going to select the point on the mid surface and then straight up to the top plate. Previously, there was always a highlight button and a preview button. Some of the dialogues, you'll notice the preview is now gone, but if you select highlight, it does the same thing, right? It gives you a preview of the vector that you defined. So I'll say okay, and then confirm deleting the plot only elements, yes. And now we have, if we drop down elements, we have 4,832 hex elements. So the next thing I want to do is eventually we're going to, for both transitioning to the Tet Mesh and for applying some loads, which we're going to do in as a next step, we need to associate this mesh with the solid. Since we extruded, it's not attached to the solid, so we can do that now by saying modify associativity. I'll say automatic, and then I'll select all the elements, and then select the solids to automatically associate, and I want to grab the base plate solid, and I'll say okay. I'll let the default tolerance. And now to confirm, we can say list model element, and we can say method on surface, and we can pick a surface and highlight. So now we know that those elements are indeed attached to the geometry. So the next step is to Tet Mesh the cylindrical body, and when we do so, we'll have to define that we want to transition. And the way it transitions is with pyramid elements. So you can transition from a hex, right, a quad, into a tetrahedral mesh using pyramid elements. And so all you have to do is tell it that you want to do that, and then flag the surfaces that represent where the where the quad faces or the base of the pyramids are to be. So the first thing we'll do is set the sizing on our cylindrical body. So we can say Tet Meshing, and we can say element size. We'll do the same element size of 3, and we'll say OK. And now we can say Mesh Geometry Solids. We can select this solid and say OK. And notice there's an option here: surface mesh only, Tet mesh only, or Tet pyramid mesh. So I'm not sure if it was just smart enough to know that I have hex elements in my model, so it defaulted to Tet pyramid mesh, but it did, so I'll leave it there. And then on the right, you'll notice pyramid mesh options. Our hex elements are linear, right? So we want to match adjacent linear elements. If they were parabolic, we would say match adjacent parabolic elements. So we'll say adjacent linear, and then we can set the pyramid locations. Oops, I need to move this over. We can set the pyramid locations by selecting the surfaces. So if I turn that body off, I think I can choose those surfaces. Can't remember if I have to choose the surfaces on the tetrahedral or not. Yeah, that's what I need to do. So I'll turn the base plate off and grab that surface and say OK, and then OK. And here we have our Tet mesh. And if I drop down by shape, I'm going to turn surfaces off for a moment. You can see if I highlight, there are our tetrahedral elements. They're the pyramid elements that help transition. And we have the wedge elements and our hex elements. So if I turn the tetrahedrals off for a moment and we zoom in, we can see our pyramid elements transitioning. And if I turn on nodes, what you'll notice, if hopefully you can see, is we have mid-side nodes on the triangular faces of the pyramids, right? Because we have parabolic tets in the cylinder. But the mid-side node is left off where it's adjacent on the quadrilateral face that's adjacent to our linear hex elements, right? So this is a new feature which gives you a lot more flexibility to transition solid meshes and gives you the ability to mesh with hex elements more frequently. And I'll also mention, and we'll show a slide on this later, if you go to Modify, Update Elements, Connect Linear Parabolic Elements, there's a nice tool here which helps you to mesh and connect and transition from linear to parabolic elements. And you might want to do this to, if you might want the parabolic elements in a critical stress region, but then to, limit the size and the number of nodes in your model away from those critical areas, you can transition out to the linear elements. And so now this tool helps you do that. It's always been possible in NASTRAN, but now Femap really has a tool to support that meshing ability. Okay, just a few more things that I wanted to show you in this live demo. We're going to create some bearing loads. Before we do that, I'm just going to create a simple constraint set. And basically, I'm just going to say on surface, I need to turn the base plate back on, and I'm just going to grab the surfaces of these holes, and I'm just going to pin the translation on those. Pinned, no translation. Okay. And now what I'm going to do is we're going to create 2 bearing loads on the end of this slotted hole. And this is a new feature, new ability in this latest release. So I'm going to call the first one bearing load 1. And to define a bearing force or a torque force, you can say on surface, on curve or on surface, and I'm going to select this surface, and I'll say okay, and then I'm going to change the type to bearing force. And now we have a few different options in here. So the first thing we're going to do is define the total bearing load. So I'm just going to say 1,000. And then when we click OK, it's going to have us define a vector that defines the direction, the primary direction of the bearing load. And then the load angle, it's going to distribute the bearing force, this total 1,000, I guess we're in newtons, from that surface. So if my angle is 180 degrees, it'll go 90 degrees to the left of my vector and 90 degrees to the right. So in this case, maybe we'll do 160. And then you can specify that the load acting on the surface is either normal to the surface or not. So this first time we'll say normal to surface. And the traction load option basically turns it from a bearing load pushing on the surface to a traction load that's pulling on the surface. So we'll just say normal to surface. Okay, and then the direction, we're just going to do the plus Y direction. I'll say okay. And if I turn on loads, I'm going to just turn off elements and surfaces so it's easier to see, and we will zoom in. And now these are, Femap is displaying them as a total load on a surface. But if we want to see how Femap is going to translate that to NASTRAN input, to nodal loads in the NASTRAN input file, then we can say model, load, expand. And then we can say convert to node element. Say okay, and then yes. And there we have a distribution of bearing forces. And if we want, I can scale these by magnitude. And what you can do is you can see we have a low load value on the ends, and the load is peaking up at like 42 at the center in our primary bearing direction. Right, and so that's, if we turn on our mesh, we can now see that those loads are defined right at 160 degrees of the circle mapped onto our nodes with the appropriate magnitude for the type of load we are specifying. So let's do that one more time. I'll say load new. This one I'll call bearing load 2. And I'm going to pick the same surface. It's already on bearing force. I'll do 1,000 again. This time we'll set the load angle to something more narrow, maybe only 90 degrees, and we'll uncheck normal to surface. So this time all the load vectors are going to stay in that plus Y direction that we define. So I'll say okay. And then again, it's showing it as a load on surface, so I need to expand that load to see what it looks like on the nodes. So I'll say model load, expand, convert to node LM. Okay, yes, and there we go. Now it's contained within the 90-degree angle we specified, and all the vectors are in the plus Y direction. So this new load definition within this release of Femap gives you a lot more ability to quickly and efficiently prescribe accurate bearing loads based on the bearing distribution that you expect on that surface. So that's a pretty cool new functionality. So the last thing I wanted to show you, and then we'll hop back in the slides and go over just a few other important new features. And then we'll answer questions. But the last thing I wanted to show you is regarding the buckling analysis. So what I'm going to do is I'm going to activate load set 1, and I'm just going to create a new analysis, and I'm just going to say buckling. Okay, Now if I drop this down and look at the boundary conditions, we have constraint set 1, load set 1. And if I preview the input, here we have our buckling, our SE buckle analysis called out. And we have our master constraint, constraint set 1. And then we have subcase 1, load 1. So that's our static subcase. And then subcase 2, method 1, that's our buckling case, right? So that's where it's solving the being told to solve the eigenvalue problem relative to the load introduced to the model from load set 1. Okay, so now in past versions, if you were running a buckling analysis with multiple load cases, you would come here and you'd say multi-set, and then you'd say constraint set 1, load sets 1 and 2. You'd say, okay, now you've got your two load cases, right, with boundary conditions 1, load 1, and boundary condition 1, load 2. But if we preview the input, what we see is we have static subcase 1 with load 1 and static subcase 2 with load 2. But what we don't see are any of our buckling cases. Now this was an oversight, and that's why we're bringing it up in this webinar. It's a slight oversight by the in this new release, and they're going to fix it. But the reason this came about is because they've added a lot more capability to manually control and define and set up stat sub cases, which can be used for preload, for buckling, and then in the advanced, more advanced solution sequences like the new multi-step nonlinear solution 401 and solution 402, which is the nonlinear kinematic solution sequences. You can do things like nonlinear pre-stiffening, and basically those stat subs have a lot of use cases within those solutions. And so right now, if I wanted to do buckling on multiple load cases, what I would do is I'm going to copy my static load cases. So now I have my 2 static, and then 3 and 4 are going to be my buckling cases. And to make them be my buckling case, I'm going to drop it down. I'm going to highlight stat sub, and I'll say edit. And then load case 3 is the buckling stat subcase for load 1. So it's a buckling subcase, not a preload, but buckling load 1. Okay. And now if I drop down stat sub, I see buckling load stat sub 1. That 1 references static load 1. And I can do the same for 4, but I'm going to choose load 2 this time. Now if I preview input, now I've got static load case 1, static load case 2, and then my buckling subcase, right, stat sub buckling 1, right, and then subcase 4 is my stat sub buckling for load case 2. So now it's properly set up. So if you have many load cases, that becomes a bit of a manual process. Like if you have dozens or 100 or hundreds. And in previous versions, when you clicked multi-set and selected the multiple load cases, it automatically created those buckling stat sub cases. So if you are doing buckling analysis in version 2019 and you have many load cases, they sent us an API that serves as a workaround to auto create those so you don't have to do it manually. And then in the next release, if you do multi-set for buckling, a buckling analysis, it'll auto create all of them. So they're going to fix that. But so right now, it's just a simple manual process to define the stat subs, or you can request the API from us. Just email us and let us know, and we'll help you out. So hopefully that wasn't too confusing diving into that, the case control of a buckling analysis, but we felt that was an important issue to share with you. So I'm going to go back to my PowerPoint slides, and we'll review some of these new features, and I'll point out a few other ones, and then we'll save a little time for questions. So I already went over this, the Windows Explorer, the icons. We talked about select all, the pick visible, and the reset button. And when you go into the pick menu, there's also some select visible options, right? By color, by model data, by output, and you can say these are visible only. So if you have loads, constraints, regions, connections defined on a solid or on geometry, when you edit the geometry and you do split operations, those loads and constraints or boundary conditions or the connections will propagate, so the definitions won't get messed up, and they'll propagate onto the new solids. And that's what's shown here as well. Solid data tracking through those different entities. So once it's sliced, they all propagate properly. So you can see going from the constraint on one surface to a constraint, this same constraint on two surfaces. We talked about the bearing and torque forces. They now have a new feature, modify project nodes radially or spherically around a point, which is a cool new little feature. This is one we didn't talk about. This is similar to the mesh extrude in both directions that we did, but this allows you to extrude elements through a sweep, but you don't have to reference the sweep path with geometry. It can follow element edges and sweep and connect and merge the nodes as you go. So that's really cool. And so you can see those shell elements are just swept into solid elements that then follow the element edge and merge nice and neatly. And there's just another view of it. And here, same thing, you can do it with beam elements. So here they're extruding this beam with thickness turned on, beams or plates. I guess this is, yeah, I think this is a beam connecting to plates. And same here, they have, you can see the beam cross section, and they just sweep it around the edge, and it sweeps into plate elements, which then merge to the existing mesh. And then this feature, this is what we did. We transitioned from hex to tet using these pyramid options. They have a few examples showing this, and right, it's the same thing I was showing, how the mid-side nodes are there adjacent to the tetrahedral elements, but on the pyramids, the mid-side nodes are not present adjacent to the linear hex. This is, and then I mentioned the connection tool to transition, help transition from linear to parabolic. That works for both solids and shell elements. Here it is showing it transitioning from the linear elements to parabolic. So you get this 5-noded element, which you can define in NASTRAN as a five-noded plate element. And there's not an explicit form for that to create that type of element in Femap, but this new mesh connection tool allows you to do so. More, along normals to surfaces is another option added to the element extrude menu. And we did extrude in both directions. And then, so here's a big one, right, is solution 401, which is relatively new, but now Femap supports it in a much more comprehensive way. And there's been a few other improvements to optimization, but the solution 401, the multi-step nonlinear, Femap is now supporting in a much more comprehensive manner. And here it is talking about the different subcase types that you can define for solution 401 and 402. It looks like they added frequency and harmonic response to design optimization. So if on any of these that I'm glossing over, if these are things you're interested in, definitely reach out to us and we can offer you a little bit of support in getting started in a little more detail. And then this last one is on solid elements. You can define a solid material coordinate system per element, not just per property. So they can all have the same property, but each element can have its own material coordinate system. So that's a new and nice feature as well. There's more translator options added in for ANSYS and Abacus. And then if you're an aerodynamicist doing Flutter analysis, you can now plot the aero mesh displacements, which you couldn't do before. You just have to import them from the F06. And then this is just a new contour option that's in the contour menu for contour plotting. So thank you very much. I'm David Cross. If you have questions, definitely feel free to reach out to me either by email or phone. Marty Civic is our Director of Sales. You can reach out to him as well if you have questions about training or support or software purchases. But with that, are there any questions that we might have or might need to answer? Let me know, and when we sign off, if we don't get your question answered, we'll definitely take the time to follow up with you in the next day or two with some answers to your questions.
So David, so far 2 questions have been asked. The first is, what is the bearing load distribution function? Have they exposed the function to us yet?
So I did not see that. You could probably, I was wondering the same, and they have the more detailed PDF version that's like with all the release notes, and it may be in there because I just skimmed that section. I haven't read it in depth yet, so I'll look and see if I can find it in there. If not, we can reach out to the Femap team and ask them, or we can certainly probably just set up a simple example and back calculate it. Yeah, I don't know if it's like sinusoidal or quadratic or what, but it looked to be. Sure, go ahead.
Another question on bearing. Can you do the bearing load on curves?
Yes, the bearing load works on curves the same way as on surfaces.
And then one just showed up. When coordinate systems for solid elements are applied, do you know how that will be implemented in the NASTRAN deck?
I'm not sure because I haven't done it yet. Let's see. Writes reads NASTRAN MAT CID card. So I guess I'm not. Yeah, so I don't know if the MAT CID card, I'd have to go and look and see a little bit more about that. I can follow up with you with the details on it, whoever it is asked the question. But otherwise, you may be able to find your answer in the quick reference guide. If you just look at MAT CID, it may explain, spell out a little bit, and you may understand what Femap's going to do. But I imagine the answer is right there with the MAT CID.
Okay, that's all the questions.
Okay, well, thank you everybody for your time. It looks like the Femap team has added a lot of capability. They continue to improve the software and listen to user input and feedback. So if there are ever features that you're interested in having in future releases, we can we love getting that feedback. Because we have a lot of those ideas ourselves as engineers who use the software every day. So thank you for joining the webinar. You can email me or call me with questions, and you can check out our YouTube channel or our website. Just go to Structures.Aero, or at YouTube, just search Structures.Aero and you'll find us. Thank you very much.